Hello YouTube, I am Jay Burden. I'm an electronics hobbyist. I create solutions for my other hobbies such as smart home solutions and advanced toys and games for my kids and youth organizations that I volunteer for. I run a couple of small businesses, one of which relies upon my innovations from this hobby. I'm currently creating a series of how-to videos to help my kids and youth that I serve in our youth program and making these tutorials available to all of you out there as well. Hoping you may find my videos interesting or useful. All of my videos will center around the ESP32 WROOM chipset for the most part, as I have found that to be the most well-rounded and pretty affordable processor. I also use Arduino IDE as my C+ encoding tool for reference here on the screen. Today I'm going to be going over the basics and defaults of Arduino Sketch. What we're going to do is we're going to cover what the sections mean, what type of sections are in the sketch, annotation methods and why they're important to use, using headings to have code sections stand out for you as you get started doing coding, and organizing the sketch via the code sections for easier reference later on, establishing the serial monitor so that you can use it to debug your code at a later date, and then saving a default template that you can use later on and making it to where you can't override it when you're saving. Okay, so getting started, let's talk about the main sections. So the first section is the section you actually don't even see here. So the one before, there's an area before that you can use before this setup section of your code, and that is used for establishing and identifying variables in your code. Okay, so this is where you would want to define code sections, all right, or even call out libraries that you're going to reference in your code. And so that is the first section. So I'm just going to make a note right here. Right here, I can define variables and reference libraries to support my code. Okay, so that's what this section is basically used for. I'm going to return an indent a second here. Right there. There you go. Oops. Wow. Struggling here. Okay. So that's what this section is for. Now, what's really cool is this section right here is also the same right here. So you can actually put things anywhere you want to, so long as the definition is used that's inputted in here for defining a variable or referencing a library happens prior to where it's used. If it's used in the loop or used in the setup, it's totally fine. So you can use this section as well. You come down here and use this section, it's not going to work so well in order to reference something that's going to be used in the loop, right? You can actually use it here if you have what's called an object below it, all right? Now, objects are very interesting too, and I'm going to put this here as well. I'm going to put in reference libraries and objects. Okay, objects are what are used to do sections of coding that can be referenced and called for in either the setup or the loop section. Okay, and we're going to talk about the setup and loop section in just a second. Okay, so I'm just going to update that real quick because I did not include that. All right, now when you first see the setup section, it says void setup, right? And it says put your setup code here to run once. That's the key indicator here, right? This is a section of the code sheet that's only going to run on startup. It's the first thing to run after it verifies and sees anything that's defined as a variable, etc. The setup's going to run as the first process, and it's only going to run one time. That's huge and key to make sure you understand that this is what's used basically to run and set up anything that you need to use later on in your loop, which is your main code, okay, that continues to run repeatedly, right? So the loop section is the process and part of your sketch that will continue to go over and over and over again continuously every single time the Hertz clock is ticking on your processor, right? So every single processor makes a process and runs through, it's going to go through this loop real fast. To a certain extent, right? It depends on how big this code is and how long it takes to go through the loop in this section. But yeah, this is where everything just goes over and over and over again. So you make sure you understand how that process works. And this runs once and only at the beginning. Okay? Now, that in mind, we talked about references and libraries, etc. Now, we need to understand how annotation works too. Very important. Okay? In fact, you can see a form of annotation that I just put in right here when I just copied and pasted this section for what we're doing today. Okay? And so this is one really cool format to do if you're going to put a bunch of information together into one section, a bunch of notes, etc. This is really good. And it's simply done by typing in a backslash and then an asterisk. And then all of a sudden everything behind it and below it goes into an annotation form. An annotation is something that's not transferred and brought over to the machine code for your actual processor or device or components, but it's something that's only used within the Arduino Sketch tool, right, for making your code. So all this stuff that's in this won't be included in my machine code, but it's here only for reference for me with the Arduino IDE, so I can see notes and stuff I plug in here to reference. Now, as you saw, as soon as I typed it and pressed enter, it created an automatic return and closed the brackets for this section. So that's really nice, and it's something to keep in mind. Anytime you want to use this forward slash and asterisk, you want to just press return, and it creates that indentation. And here in this note section, we can type forever. And every time I press return or enter to indent again to the next line, it continues on with these asterisks to identify the section. This is a very good and useful tool for annotations for putting lots of notes in. The next thing is the next main method for annotation is this guy right here, 2 forward slashes. Okay, 2 forward slashes are really cool because it allows you just to put a single one-line entrance in there. As soon as you press return or enter right here, it's now back into the code. So anything with 2 forward slashes is going to be used only just for the one entrance and not included in your sketch, just like this would not be in your machine code that's transferred to your device. But this won't be transferred either, but a good note for you to put a little single line notation in here. Now, why is it important to do this in the first place? Well, here's the thing. When you start doing a lot of coding and over time, right, you're going to go back and try and reference it. And after you do one or two, several different codes that you have to go back and forth to, you're going to forget things. I am a very forgetful person, and I will forget what the heck it was what I was doing when I was typing a certain section of code. And putting notes in there for what parts and pieces of the code do, as well as what the purpose is, and some expanded notes sometimes as applicable, will help you to have references whenever you come back to those codes to make modification, updates, or changes later on. Okay? Or even reusing that code section for another as an example for a new code you're working on. And trust me, as you get into coding, that's pretty much all you do. Now, at this point in time with my coding, mostly I do is go back and I look at old codes I do and remember when I did something, and I don't remember how I did it. So I'll go back, review it, review my notes, copy and paste a section of code that I like, that I want to use, and then bring it into the new code and modify it to match what I'm trying to accomplish. So that's why having notes in your code are extremely important for you to reference, as well as anybody in the future that goes and works on your code to collaborate with you later on. Okay? All right, so we know that this section is right here. I can define variables, right, on these. I'm going to put, to make sure it's clear, right, this is not part of my code. And as soon as I put in 2 backsplashes, you can see the color slightly change on the lines, and it's no longer as dark as it was before. See, watch, it's very dark, 2 slashes, and I put a space in there just to get it off of the brackets. It's now a lighter color to make sure it's not something there, right? Now you'll see things like this color green sometimes. The color green is indicated for functions. Sometimes you'll see red things that are in the code. Those are things that are already predefined within some of the included libraries that are always included in the Arduino IDE, and it'll make colors red or green depending on what the actual command you're using is used for. Okay, annotation hopefully is explained and pretty clear. All right, and sections, I think we should be pretty clear on what they're doing. All right, with that, let's talk about one basic thing that we're going to make sure we include in every single sketch we do, okay? And that is our serial monitor, okay? There is absolutely no code I've ever done that did not have a serial monitor using for anything else. It's primarily used for debugging for me, right? So that I can go back and look at the inputs and the outputs, etc., for what's going on and how the code's responding to what I'm doing and how it's interacting with external devices or even processing internally. That way I can make sure that it's doing what it's supposed to be doing to troubleshoot it, right? So we're going to do that right now in the setup section. That's where this is done, because it's done. The setup is one time, and then the loop is whenever you process and actually carry out the exercises that's built in for creating this program or this section of code. So we're going to go 2 backslashes, and we're going to say we're doing serial port setup for debugging purposes. All right. Now, I just define what I'm going to do with my annotation, and I'm going to now write the code to create or to initiate the serial port functioning on my ESP32. Okay, so here we go. Serial.begin. Okay, now you see how that turned red? That's because in the built-in standard libraries that the Arduino references, this is a command and it recognizes this command. Okay, he knows what this is, right? So serial.begin. Now I'm going to set the baud rate, which is how fast the information is supposed to stream on the port built into the ESP32 for what I'm going to use. Okay, I'm going to put those in parentheses, and really quick, you saw as soon as I close this, whatever this bracket is, right? It automatically created a little indication that it recognized that it closed the bracket. That's something we're going to look for a lot in our codes too, to make sure all of our groups are closed, okay, and make sure that we don't mess anything up. Watch, if I click behind this one, you see that it knows that this is also a certain type of bracket that's used, and this is a type of bracket that's used, right, to make sure that these things are closed. That's very important to verify as you're doing your coding. Okay, now we did serial begin, and we started at this baud rate, and we're going to we're going to do one command, serial dot print line. And we're going to say serial monitor started. Okay, what this did was it called the same command that I just started, serial begin. It called serial again. It says, hey, serial, right? This is your section of code that's built into the libraries and firmware already in Arduino that's going to be transferred to my device. It says, hey, you, wake up. This is what I want you to do. I want you to print a line on the screen, right? I want you to send some text data to my monitor, right? And say, this, and I put it in parentheses to say what it is. Now look at how it turned green in parentheses, because it knows and recognizes that this is specific text, right? Specific text that wants to be printed to it, and it's going to use this data, transfer it into machine code, and then to something that the computer can read and print it on the screen. So that's all we're going to do right now for this sketch, except for saving this as a template. Okay, so I'm going to just do another note here to clarify that right here I can define variables, reference libraries, and objects to support my code. And it needs to be referenced below this section. Okay, now I put that in there because it's imperative to remember that this only works, right, if it's below the section, right? I'm going to put this in there and put a couple spaces to know that this continues. Okay, so this is what we're going to do. We're going to take these items, can copy them, and then change this. Okay, put that in there as well. Go right here. All right, so we know the sections are good, right? Oh, and one more thing before I get to the saving. I am going to put in some headings, okay? So I'd like to see headings. So this is what we're going to do. We're going to go, we're going to make something stand out and be big, something that's easy for me to find, because whenever this code gets 200, 300, 1,000 lines, 2,000 lines of code sometimes, I want to make sure that my sections are easy to find, okay? And so, I find those by either searching for them, right, by heading titles and stuff like that, or by big standout letters. And I do both of them this way, and here's how we do it, okay? So I'm going to go right here. I'm going to put in a slash. I'm going to put a bunch of asterisks across the screen for as large as I want the screen to be, okay? And I'm just going to make it this wide because that's how the length I like. Now, all of these asterisks will not be read in the machine code because it's it starts by 2 forward slashes. Okay. Now I'm going to put in a few more right here. I'm going to put a couple spaces. I'm going to say library and library inclusions. Okay. And I'm going to close this just so it stands out like that. And then I'm going to do this again so I kind of make this guy very, very clear that it's there. And if I want to get very nitpicky, I can go ahead and center this a little bit more, delete some lines, right? Put in some more asterisks here. Make it so it's centered. And I'm like, okay, that's cool. I'm happy, right? Oops, I didn't do asterisks. Oops, there we go. Okay, so now he's centered. He looks pretty, right? And that's my heading. Okay, then if I want to ever search anything, forget to the real shortcut to library inclusions. All I have to do is do a Control F, right? And find library inclusions and type it into the search bar. Okay, now I'm going to take this section. I'm going to copy this. Okay, and I'm going to go down here and I'm going to do the same thing for the loop setup. Okay. Setup section. And I'm doing that because, again, visual stand out so that I can see my setup. Okay. I'm going to come down here to the loop, right? I'm going to go boom. I'm going to change this to main loop. I'm going to throw some more asterisks to make this level or even. And there's my main loop. Okay. Right? And that's it. All right. Now, normally in my codes, I try and put all my library inclusions up here, set up here, loop, main loop here, okay? And then I actually use objects before the setup in the loop, right? Some people will put them between setup and loop. Some people will put them after the loop, right? For all the objects that are going to do it, which is basically small sections of codes to be referenced to in either the setup section or the loop section to be called for. Okay, but I like to do it here. Okay, and so now I also actually like to identify my definitions. Okay, so I'm going to put it right here. I'm going to take this, delete that, and delete this. That way, it's clear. Right here, I can define reference libraries. Right? Boom. Now, I'm going to come down here. Boom, paste this, and I'm going to say variable declarations. Okay. Now I'm going to say right here, boom. Okay. And that's where I do my variable declarations there. Now I'm going to take the same concept again. Boom. Oops. Take this guy. And we're going to say this objects. Again, an object is basically a subprogram, right? Part of the main program that's used and called for either in the setup or in the loop, okay? So now that's understood. While I can use these sections for those things, right? And if you can do this on your own if you want to, right? If you want to use those sections for defining and putting in objects, variables, calling libraries, you totally can, right? It doesn't make a lot of sense to put definitions at the below the loop or below setup unless you're only using it in the loop, right? and it won't be called for if you put it below the loop in the loop, right? So you can't define an object or define a variable here. You can't call a library here. It won't work because it needs to be called from above. That's why for me, it's just better management to have all this stuff in the very top of your code and reference it in those sections and have it always there, and then you just know where you keep your stuff, right? Now, I know that there's a lot of coders and a lot of people who do YouTube videos and representation instructionals, and they have all the codes down here, and they have all their objects down here. That's totally fine. Objects can be done anywhere you want, right? Variables and libraries have to be called before they're used, though. However, objects are different. The subcodes, subprograms, etc., those can be called anywhere you want to stick them outside of the sections from here, right? However, they have to be. They have to make sure. You just have to make sure you do it right, because it gets complicated. And that's why, for me, it's just better to keep them up at the top, right, in that one identified section. Okay, let's go ahead and file. We're going to file and save as. Okay, and I don't know if this is going to pop up, but I'm going to save this up as a default. Okay, default ESP32 template. Okay, I just saved that as a save as, and once I'm done with that, I'm going to switch over to my desktop now to show you how to make this to where I can't save over the file, that I have to do a save as every single time. I'm going to show you that in just a second. Here, let me switch over to the desktop. Okay, now since we went ahead and saved this sketch as a program, if we go to Sketch on this section and we click on Show Sketch Folder, it's going to show us where it's saved to. That'll pop up on the screen for a new folder, a new location that was created, a subfolder. It says default ESP32 template, which is all within the line of whatever this is saved to for my default settings on my Arduino. Now I can modify this right now. But in order to do so, I need to close the program, because otherwise it won't let me save over the program. So I'm going to open this, make it big, right-click on the file, and go to Properties. And I'm going to make this a read-only document, read-only. Okay, once you do that, you hit Apply, OK, and it made this now so you can no longer save over your default template file. So if you ever need to start from scratch, which we're going to be doing a lot of, to get some of these programs done, and do some copying, pasting from previous codes we do as I go through my how-to tutorials. And if you try and make any modifications to this now read-only sketch, and I go File, Save, it's going to say no. Some files are marked read-only. You'll need to resave the sketch in another location. Click OK, and it automatically make you save it as a new file and call it something else. Okay. I'm not going to do that right now, but that concludes what we're trying to accomplish with this sketch. Thank you so much for joining me today, and have a great one.